In this video, we will continue Hhellwach and Lenards experiment for potential current graph. Now this will be the graph. So this is potential and this one is current. So this is photoelectric current. Now I am going to use an intensity of light having I1 and I2, I3 and I4. So for intensity of the same frequency light, for example, different intensity of red light. So red light, if I'm keeping the same color for all the intensity, I can say that I have fixed the frequency and varying the intensity. Now this intensity is less, so I1 less than I2 less than I3 less than I4. Now as of now I am going to keep this circuit. I am not connecting any potential difference here. I am just connecting these two just in this way. So it's just a conductor in between two metallic plate and an ammeter connected in this way, which means potential difference in between these two is 0. So this is the potential, right? This is the point where 0 potential difference is represented. Now I am going to switch on this light. Now the light will come from the source and that will be incident on the metallic plate, which is emitter plate. Now what will happen? For example, as of now it is neutral. This is neither negative, this one is not positive. It's neutral. Everything is 0 in charge. All the parts in this experimental setup is carrying a charge of 0. Okay. Because I am just straight away connecting these two. When light ray is coming and getting incident over an emitter plate, electron will be given out. So now what will be the charge of this plate? That will become positive because this has lost electron. Now this positive charge will be immediately transferred to the other plate. What is the reason? See, this basically happens due to the fact that the electron from here will be moving through this and will reach here. The electron will reach here. This will make a no charge here and this will be now charged by positive. Now this positive charge will attract this electron. So here when I am not connecting any potential difference, at every moment when an electron is given out, this will become positively charged. How this is possible? Because this is conductor. The moment this becomes positively charged, this positive charge will be immediately neutralized by electron from this metallic plate and this now will become positive charge and this positively charged collector plate will now attract electrons towards it. What I am saying is 0 potential will be capable of giving a current here. So at 0 we have a current. Now when I am increasing the potential, it will give more and more amount of current. Now so to increase the potential, what I will do, I will just connect this with this. So this will be now connected to positive terminal and this will now be connected to negative terminal. Now at V1, a lower potential, it will be higher current. At higher potential, higher amount of current, I am keeping on increasing the voltage. The current will also increase. But after certain point, that will be saturated. This is called as saturation current. Because now the emitter plate doesn't have electrons to give out, which means the charge carriers are not able to give further after this saturation current. Now what I am going to do is, see, I am just keeping the connection in this way so that this will now be connected to negative and this will now be connected to positive. So when this is connected to negative, what will happen now? This will become negatively charged or negative potential. Now the electrons which are given out from the positive metallic plate will be repelled by this negatively charged sheet or with the negative potential. See, now this is negative potential. Let's say an electron is coming out. this was previously moving towards the positive plate, but this has become now negative charged plate. So what will happen? This electron will be repelled by the negative charged sheet. Okay, so this electron cannot move towards this. But not all the electron. Some electron will have high energy, so this electron can overcome this repulsion due to the negative charge sheet. So this will be now moving from positive charged plate to negative charged plate. Only those electrons that has got higher energy that can overcome this field and can move to the other side. But for example, just for example, this has got this energy. I have 5 electrons coming out from the positive charged sheet, the metallic plate. One is having, these are just example, just number 50 joule, 40 joule, 30 joule, 20 joule and 10 joule. These are 5 electrons. So these electrons has got this much amount of energy. Now see, when I am giving a negative potential here, what will be the value of potential? V0. Let's say this is V. Potential at this point is V. Now when an electron is kept here, now this potential will be able to give an energy at this position. That value is EV. And with that energy, it will have a tendency to move in this direction. I'll repeat it. Now the moment I am connecting this with a negative potential, negative terminal of the battery, this will get a negative potential, and this negative potential will give a negative potential at this point, and due to that fact, every electron coming out and reaching or being at this position will get a potential energy of E into V, and this will, and what will be the tendency? The tendency will be to go backward with the energy. Okay, but those electrons that has got higher energy in this direction will be moving towards it. Okay, now let's say the energy due to the negative potential on an electron, if it is 30 joule, what will happen? Out of all these electrons having 10 joule cannot overcome this, because this one is 30 joule in this direction. I mean, for energy I can't define any direction, but I can say that with this energy it will have a tendency to move from this position to this position. Okay, see, for example, I have an electron here. I am keeping a positive charge sheet here. This will have a potential at this point. The value will be E into potential at this point. That will be the potential energy here. From here it will come here, which means this is the point where it is having lower potential energy, and this is the point where it is having higher potential energy. Okay, so basically positive charge will move from higher potential to lower potential, and electrons will move from lower potential to higher potential. Anyway, leave it. I can say that it will move from higher potential energy to lower potential energy in the case of positive charge, but in the case of negative charge it is just the opposite. Okay, so when it is 30 joule, 10 joule and 20 joule will be stopped at that position. It cannot cross this and reach the collector plate. Even 30 joule will also be stopped, but 50 joule and 40 joule can reach here. So that is, I am just giving the negative potential. Now current will decrease because these are stopped now. Now when I am increasing the potential to next point, now I am increasing to 40 joule, the negative potential. So 40 joule is associated with the potential here, right? Because potential energy is equal to Q into V. So this is the potential and this is the potential energy. Now potential energy is this, and this will be associated with the potential here. Now that potential will stop for electron with 40 joule as well. Now all electrons with 50 joule will be coming. Now 45 joule will stop all the electrons having 45 joule, and only electrons with 50 joule and above 45 joule will be passing through this area in between the plate. Now we will increase that value, and finally I will give a potential that can stop the electron that has got the highest kinetic energy. Here in this case 50 joule. So out of all these, if I am giving a potential that represents 50 joule, what will happen? All the electron can be stopped. Now if all electron is stopped, what will be the current? That will be 0. So this is the graph. This is called as V0 or stopping potential. So at stopping potential, every electron can be stopped, which means it will not move from emitter plate to collector plate. Any other potential, some of the electrons are stopped, but some of the electrons are moving. That will make a photoelectric current here. At 0, there will be photoelectric current, and after that, on increasing the potential, that will increase, but that will reach to a saturation current at one point. Now this represents intensity 1. Now I am going to do the experiment with the next bulb that has got I2 intensity, where I2 is greater than I1. Now we will get a graph at 0 potential. This will be the current, and afterwards it will increase, and this will be the graph. But on reversing the voltage to stop the electron, what we have seen is the graph will go in this way. Now we have seen that with intensity I1 and I2, the graph is different, but the stopping potential is the same. So what does stopping potential represent? That the electrons having highest kinetic energy. Okay, so at stopping potential, those electrons that has got highest energy can be stopped. Now how come electrons can be with different energy? Let's say this is the metallic plate, and I have an atom here, I have another atom here, I have another atom here. Now light ray is incident here. Now this atom can immediately give an electron because these are very close. These electrons are very close to the surface, and this can just cross the boundary, having maximum energy. Now when the same light is incident on this atom, what will happen? Electron will come out, but it has to travel this much distance. So some of the energy will be used, only remaining will be available. So energy come back to this will be less, but it's the same radiation. Now here it has to travel this much, then only it can come out. So energy will be less. So with the same frequency, we are getting electrons with different maximum kinetic energy. Okay, different energy. So this one is having the maximum kinetic energy, and all other are having lesser kinetic energy. Now I am saying that at stopping potential, I can even stop the electrons having the highest kinetic energy. So all the electrons are stopped at stopping potential. Now with this experiment, I am able to conclude that stopping potential is independent on intensity. Whatever may be the intensity, the electrons that are having highest kinetic energy is the same. With I1, with I1 intensity, if the maximum energy of the emitted electron, if it is 50 joule, with I2 also it is 50 joule. That is the reason at the same potential I am able to stop the current due to I1 intensity and current due to I2 intensity, because the maximum energy is 50 joule. If the maximum energy due to I2, if it is 100 joule, then at this point I can't stop the current, because all the electrons that have the energy in between 50 joule to 100 joule will not be stopped. So this means that the maximum kinetic energy of electrons emitted out with intensity I1 and I2 is the same. Now with I3 I have done the experiment, it goes in this way. With I4, when I have done the experiment, it goes in this way. So these are the saturation current. Now this is the stopping potential. Very important takeaway is stopping potential is independent on the intensity. Okay, thank you.